Day 301 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 78, subsets. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description and get you some. Now let's see what the question says. Question says, given an integer array nums of unique elements, return all possible subsets, the power set. The solution set must not contain duplicate subsets. Return the solution in any order. So y'all, that sounds simple enough, but let's go ahead and take a look at these examples so that we can make sure we're doing this question correctly. Now, the first thing we want to do is we want to see what the definition of subsets is. So it says a subset of an array is a selection of elements, possibly none of the array. So that's important because as you can see in our output, it starts with a blank array, right? So it says the possibly none part is important because it's a blank array included in our output. Now let's go and look at go through these examples. So in example 1, we have the input nums equals an array of integers 1, 2, and 3. The output is a 2D array of integers. The first array being a blank array, the second array being 1, third array being 2. Then 1, 2, then 3, then 1, 3, then 2, 3, then 1, 2, 3. Now, as you can see, all of these arrays inside this initial array, you can see are different subsets of this input array, right? So first we have the blank array. That's just nothing. That's none. It says right here in subsets possibly none, so that counts blank array. Then we have a 1, right? So that comes from this 1. Then we have a 2. That comes from this 2. Now the 1 and the 2 are by themselves because we want all possible subsets. We want every combination that we can create with these 3 numbers right here. So then that's where the 1, 2 comes from. Then we have the 3, then we do the 1, 3, then we do the 2, 3, then we do the 1, 2, 3 to finish. But once again, just to simplify it, these right here are all possible combinations of this, and each combination gets its own array. So let's go ahead and look at example 2 where it's a little easier. It's only one number in the input. So the input nums equals an array of integers. That integer is 0. The output is a 2D array. We have to include this blank array even though it's just one element here. We still have to include this blank array because that counts as a subset, and then we can just do the 0 by itself because that's the only other subset that we can create. There's only one combination that we can create from this input, right? So one last time, we're just creating all of the possible combinations of the input, and each combination gets its own array. So sounds simple enough, y'all. Let's go ahead and get into the fun part, the actual code. And the code is just as simple and easy to understand as the question. So let's get into it. Now, the first thing we need to do is we need to create a variable which will store all of our subsets. So in order to do that, we can just declare a variable. We could call it result, and we could set that equal to a 2D array of integers. Come outside the square bracket. So that's a square bracket with inner side. Come outside the square brackets and initialize it with parentheses like that. Now, this is going to where we're going to hold our output, right? So as you can see, it's a 2D array. As you can see, our output is a 2D array as well. So that's why we create it right here. But right now, that's just to get started. Now let's keep going. Now we need to create a recursive function that's going to generate the subsets. So to do that, we're going to stay inside the main function, and we're going to create another function. We're going to call it func. We could call it generate. Then we open up the parentheses, underscore. It's going to have nums, colon. Nums is going to be an array of integers. Come outside that square bracket, that array of integers. We're going to say comma, underscore. We're going to say current, colon. Then we're going to open up the square brackets again, put integer inside. That's going to be another array of integers. This time we're going to initialize current with a blank array just like that. Now, we come outside these parentheses, we open up the brackets. Now let's get started. First thing we need to do is we need to add current to the current subset to the result. So current is going to represent our subsets, and we need to append all of our subsets to the result. So in order to do that, we just come right here. We can say result dot append, open up the parentheses, current. Boom. Now, as you can see, current starts off as a blank array, so it's going to start off appending that blank array to our result, just like it is here. Boom. Then we're going to keep going. Boom. So now we need a base case to stop recursion when there are no more elements. So we could just say if nums dot is empty, then we could just open up the brackets and we can say return. Then we're going to come underneath that, and we need to iterate through all of the remaining numbers. So in order to do that, we can say for I in nums dot indices. Make sure I spell that right, y'all. Sorry about that. Indices, just like that. Then we're going to open up the brackets. Boom. And we need to recursively generate subsets by including nums I and passing the remaining elements. So in order to do that, we're going to call this generate function right here recursively. So we're going to say generate, boom. Oh, excuse me, open up the parentheses, array. Open up the parentheses again. We're going to say nums, square bracket, put some parentheses, open up the parentheses. Inside the square bracket, we're going to say I plus 1. Come outside of those parentheses, we're going to say dot, dot, dot. Come outside the parentheses again, but still inside the other parentheses, the last parenthesis, we're going to say comma. Then we're going to say current plus square bracket, nums, square bracket I, just like that. Then we are going to come right here, boom, and we need to start the recursion with the full array. So we're going to say generate, we're going to call generate, and we're going to say generate nums. Then we're going to come underneath that. When all that's finished generating, we just need to say return result, just like that. Now, y'all, that should be all of the code. Let's go and give it a run. See if we can get this on first try. Let's see. Ooh, of course we can, because we have a typo. That should be generate, not generate, whatever that said. Should be generate. So let's go ahead and run it again. We missed our first try, but we're not going to let that stop us. It's accepted, so let's go ahead and submit it. Make sure it stays accepted after we submit it. See what that time looking like. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift. That's what I'm talking about. That's what I'd like to see. 10 out of 10 test cases passed. It's good stuff right there. I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. I'll see y'all then.